In this video, we will be discussing how to determine if two ratios are a true proportion, and then also discuss how to solve them when you're missing a value. So the first thing that we need to discuss is what a proportion is, and a proportion states that two ratios are equal. So it's a way to set up two ratios so we can determine if they're two equal values. And so to prove if two ratios are equal, we can actually do this by cross multiplying. So we can cross multiply the two ratios to determine if they are truly equivalent to each other. And we're going to refer to this as the butterfly method. And I know you guys touched a little bit about the butterfly method, I think in elementary school, at least at some schools you did, and that was how you compared fractions to each other. This is the only time that we are going to use the butterfly method in middle school. So if the two ratios are equal, they are considered a true proportion. And we'll talk about what does that look like. So if we look at our cross multiply butterfly that we have down below, we are going to cross multiply the two fractions that are there to determine if we get the same number. So you can use your pencil, you can use highlighters if you want to. I'm going to use a highlighter. So I'm going to multiply 9 times 5. I'm going to write it out, 9 times 5. And if I multiply 9 times 5, it should be the same as if I multiply 3 times 12. So 9 times 5 should be equivalent to 3 times 12 if this is a true proportion. So if I multiply 9 times 5 is 45. And then 3 times 12 is 36. These are not equal to each other. So this proportion is not true. So they are not equivalent, and this is not a proportion. So our wings don't balance with each other. Now if I do another example here and I do, let's say I do 2/3 is equal to 6/9, and we're trying to determine if these are proportional. If I cross multiply them, 3 times 6, I'm going to write that out, should be equal to whatever you do on the other end. So if I do 2 times 9, I have 2 times 9 here. So 3 times 6, if I solve this, is 18. Should be equal to 2 times 9, and 2 times 9 is 18. Because these are both equal to each other, these are considered a true proportion, which means they are proportional. So this is a true proportion because the left wing is equivalent to the right wing. So let's do some examples here. And if we look at 1, 2, 3, and 4, we're going to write yes or no if they are true proportions. So remember, you're going to do the wings of your butterfly, and you're going to test it out. So if I do 1 times 12, that should be equivalent to if I multiply the other wing out and do 2 times 6. So I have 1 times 12 on one side, 2 times 6 is the other wing, and I'm just going to multiply them. 1 times 12 is 12, 2 times 6 is 12. So yes, this is a proportional relationship. So what I want you to try to do is, let's try number 2. Pause the video and try number 2. So if we look at number 2, I'm going to multiply 12 times 1 on my first wing. And it doesn't matter which way you multiply first. If you multiply the other direction first, that's fine. You're just trying to make your two wings. And then I have 9 times 4. So 12 times 1 is 12. 9 times 4 gives you 36. So these are not the same, which means these are not proportional relationships. Okay. Why don't you try number 3 and number 4 on your own? So if we look at number 3, I'm going to do 10 times 5. And then I'm going to do 50 times 2. And if I do 10 times 5, you should have gotten 50. And if I do 50 times 2, I get 100. So these are not proportional. And you can put that not equal to sign in between there. And then the same thing with the last one. I'm going to do 3 times 6. And then on my other wing, I'm going to have 18 times 1. So I have 18 times 1 on this side. 3 times 6 gives me 18. 18 times 1 gives me 18. So yes, these are proportional relationships. Okay, so I'm going to set you loose to do the you try on this page. I want you to do 5, 6, 7, and 8. Unpause the video when you're ready to check your work, and then we can check it together. And here are your answers for 5, 6, 7, and 8. If you have any questions, please make sure that you see your teacher before you head on to the next page. So the next thing that we're going to talk about is actually solving a proportion. So take a pause, write all this stuff in, and then we'll take a chat about it. So we can also use proportions to find missing values. So just like we were using ratio tables to take that original ratio and then multiply it further on or divide it to go backwards in the table, you can do the same thing with a proportion, but you use the cross multiplication method. So the first thing you're going to do is cross multiply. And then you're going to solve the equation for the missing variable, because you put a variable in the place that you don't know. And then you can plug the solution back in and you check to make sure, did it come out to be a true proportion, just like we did on the first page. So let's do a practice. So we're still going to do our cross multiply butterfly, but I'm going to start with wherever the variable is in this problem. So we have 120 times x, and we know that we can just squish them together to make multiplication. And then I have 24 times 75. I know that 24 times 75, I can use my calculator for this, and I get 1,800. I get 120x. Now my goal is to get x by itself, because I have to solve for that missing variable. These are stuck together by multiplication. That inverse is division. So I have to divide both sides by 120, and if you need to draw the line down the middle, do that please. These cancel, so I'm left with x is equal to, and 1,800 divided by 120 is 15. So x should be equal to 15. So if I plug in 15 right there for x, if I check 15 times 120 in my calculator, it should equal that 1,800 that I got on the other side. And if I do plug it into my calculator, I did get it 1,800. So I do know that I got the problem correct. So there's no reason that you should get any of these answers wrong. It's just as easy as plugging it in and multiplying. That's it. All right, let's do the next one. I'm going to always start with the variable. So 63 times n, or just 63n, is equal to the opposite side, which is 7 times 108. This side says 63 times n because I can't do anything. 7 times 108 is 756. If you need to draw the line, do so. Remember, I have to do the inverse operation with this 63 and the n. They're stuck together by multiplication. My inverse is division. Divide by 63 on both sides. I'm left with n is equal to, when I divide that, I get 12. You can check it by plugging 12 back in. And change the color so you can see. 12 in for n. So if I do 12 times 63, I should get that 756. If you type that into your calculator to check it, you do get 756, so you got it right. Okay, let's do another one. Start with the variable, so I'm going to deal with that 3 times x first, which is just 3x. And if you don't need to write out the multiplication like I was doing for this problem here and that one there, that's fine. If you easily know that 9 times 2 is 18, then just write 18. You don't have to write that multiplication if you don't want. The inverse here would be divide by 3. I'm left with x is equal to 6. If I plug 6 in where the x goes, if I do 6 times 3, that does equal 18. So I know I got it right to match my original side. And then the last one we're going to do together, start with the x. So I'm going to do 2 times x first, which is 2x. 9 times 8, which is 72. Do the inverse, divide by 2 on both sides. So I'm left with x is equal to, and 72 divided by 2, use that calculator if you need to, is 36. Plug it back in. 36 goes here. So that means 2 times 36 should equal 72. And it does, if I check it in my calculator. Okay, last one that we're going to do together before I set you loose. It says, at a conference there were 8 men for every 6 women. There are 64 men at the conference. How many women are at the conference? So when we do these ones, we're going to go words, then known, and unknown. So what does that mean? So first thing we're going to do is we're going to write the words of what we're comparing. Well, what are we comparing in this problem? We're comparing men to women. And our known ratio that we have in that first sentence is there are 8 men for every 6 women. Now we're going to set up our ratio for the second piece that we don't necessarily know. It says there are 64 men. How many women are there? So we know that there's 64 men and we don't know the women, so that's going to be the x. And then we can solve. 8 times x would just be 8x. 6 times 64, remember if you want to write it out, you can. So now I have 8x is equal to, and 6 times 64 comes out to be 384. I have to do the inverse operation here, which is division by 8. So I'm left with x is equal to 36. If I plug 36 back in where x should go, 8 times 36 is going to be my check step. And it should equal 384. If I check that, I do get it right. So my final answer is going to be 36. And make sure you label it. What is it? Apples, oranges, monkey swinging in the tree, coconuts. This, it turns out, it's in the women row, so it's 36 women as your final answer. So what I want for you to do is I want you to pause, and I want you to do these bottom 4 problems. And when you're ready, unpause and we can check your work. And here are your answers for 16, 17, 18, and 19. So last thing that you're going to do is I want you to solve all the problems on the page. I'm going to kind of break it up a little bit. So first off, I want you to do 1 and 2. Then you can unpause and check your work. Remember, you're just telling me, are they true proportions? Make sure you prove it. So that show me that cross multiplication. So go ahead, do 1 and 2, unpause, and you can check, and then we'll move on to the next ones. And here's your answers for 1 and 2. They both are not proportional. They're not true proportions. So what I would like for you to do now is I want you to do 3, 4, 5, and 6. When you're ready, unpause the video, and then you can check your work for those. And here is the work and answers for number 3, 4, 5, and 6. Okay, the last thing I want for you to do is I want you to do these 4 word problems. Remember that you set it up as your words, then your known ratio, then your last thing is your unknown ratio. So set it up with words. I'll do the first one with you. Kiwi fruit for $16. So we're going kiwi over money. And it's 32 kiwi for $6. And it's asking how many kiwi, I don't know, for $4. So there's how that one is set up. Go ahead and solve. I want you to solve 8, 9, and 10. Unpause when you're ready to see your answers. And here are your answers for 7, 8, 9, and 10. I apologize when I did number 7. It should have been 16, not 6. So if you didn't catch that, I apologize. But make sure you go back and fix it if you need to. For number 8, you were comparing bulbs of garlic to money. So garlic over money, and you were looking for how many garlic you can get for $32. For number 9, you were comparing soda to money. And it wants to know the cost of 1 soda, so you were looking for the money. That one came out to be a decimal with $1.25. And then the last one bunch of seedless black grapes was for $2, so 1 over 2. And I wanted to know how many bunches you could buy for $20. And you can buy 10 bunches. If you have any questions, please make sure you go and see your teacher to get help.